Now we'll just sit here for 10 minutes. We wait for this game to load. TCP has recently been released to the public. It's been out for a while, and I have seen a couple people and had a couple of questions directed to me. How do you set up TCP? How do you use it? Okay, this isn't just you. TCP is kind of just a lot to look at when you first look at it. So this thing here, the Steam Diesel, it has some TCP in it, but what I'm going to do today is just finish the TCP install on it. So step one for me is I need to clean up the engine because I've got like flow valves and filters and I think there could be pumps in here somewhere. I don't know, I'm just going to clean this up. I'm going to get rid of this picture on the side here. And I've only got one connector. So yeah, I've just got to clean it up a little bit. So just hold on for a minute. Okay, while I'm doing these connectors, it's important to know which connectors you need. Here I have my Draken, just as a reference. So I'll just pull this back a little bit and paste it in so you can see. You can see here I have lined up where these arrows are, and that should mean that these wheels are all on the same height. You can see this top connector is lined up. That top connector is an electrical connector, and that is used for transferring electricity from power generating generators into motors. So meaning if the Draken here was running and generating electricity, the generator in the front is connected to that connector and the motors in the wheels and nothing else, no electrical systems. Okay, so it's just for electricity to motors that are going to move the locomotive or the train. But what it means is that the Draken could be producing electricity and this steam diesel might not be turned on, but if it's got motors, then the electricity can be transferred through and powering these motors. And so you can have passenger wagons, and I've got the tender that have motors in them that can pull electricity from other places to provide more propulsion. That's all that one does. Below that is the main TCP connector. So this middle connector is an electrical connector, and that transfers all of the logic from wagon to wagon, locomotive to locomotive, everything. Runs over composite, and it does all your logic. All the logic runs across that. You can plug electricity into this if you want, but it's not supposed to be connected to the main generation system. So it'd be like if you have a side generator. So in the Draken, it's gone now, chopped off. There is a big generator in the front that powers the motors, and there's a small generator up the top. So that small generator could be connected to this middle purple connector, and that will help, that like powers lights and things. Then the bottom one is for fluids, and I don't know if there's any spec on which fluids, but it's a fluid connector if you want to move fluids. So in most cases it's going to be diesel. In my case it's diesel, so the Draken runs on diesel. You don't technically need those two, right? You just need this middle purple one. And the height of that, if we look at where the wheels are, I've got like one more block before I'm in the ground. So it's 1, 2, 3, and then it's the fourth one up from the ground. So yeah, if I put a block here and spawn this in, you can see we're on the tracks. This yellow block is the ground. We've got 1, 2 for this 1x2 wedge, then a block, and that is your connector. So it's the fourth one up for your main TCP connector, one block above that for your electricity, and so it's 3 blocks up for fluid, 4 blocks up for main TCP data, and 5 blocks up for your electricity, only for motors. While I'm on the subject of these, the way that I connect them is you leave all your settings default on a robotic pivot and set the power to 50%. I'll just check the back one as well. Power to 50%. So that helps it snap back to the default position, but if it needs to move to the left or the right as it goes around corners, it's got enough wiggle room to move there. Now I think, yeah, I'm using wedges behind here. Wedges have a slightly smaller hitbox, so they're not going to really mind if this wedge comes flying into them. So that's a good idea to sort of hide that and give yourself the wiggle room to not have any kind of impact there. Now, all of my logic is in here. I need to chop it out. There's a horn. I'll get rid of this horn because I'm not so sure about that horn. So anything that is related to the running of the train, I'm going to get rid of. So TCP, anything TCP, I'm going to get rid of. Okay, I think I got rid of all my logic. It's all inside the fuel tank, which is nice. So I just want to make sure that what I've got left actually works or is somewhat connected. So yeah, the fuel should be reading badly because the fuel tank is being cracked open. It's now coming out behind the furnace there. Battery is 1. We've got pump in, pump out, which should mean these are both true. True and false, and false and false. And then I have a manual valve, which should be connected to that. I'm just going to trust myself that I've done it right. These should work. They do seem to work. And these are actually more complicated than they needed to be. These little doors, they turn off the electricity to them when they're not being used. I'm just leaving these paint blocks here so I know like I can paint something there if I want. Door opens, I've got a seat. This display is one of the things that I really wanted to do, is have a 1x2 display for decouple just up here. And I have that for the Draken. So we have the speed, we have the track switch button, the horn, which I might connect to a siren, reverse, interior light, throttle and brake. The throttle needs to change slightly. And then I've got my little master panel here, furnace temp, boiler temp, battery, fuel, heater. Is there a heater in here? Now, do I want to keep this orientation? Because it is kind of weird. There's like this main thing folds down, and then there's this thing at the back, this little panel that folds forwards. So yeah, that is kind of weird. But I kind of like that. And that must be the pivot there. Oh, there's the heater. I think it's okay. You know, it's a bit of an older locomotive, and it's a bit, as in terms of when I built it, it's a bit older. So it's going to be a bit weird. So now for TCP, we're going to utilize the roof. Actually, I might make another layer because the roof's not very big. Using a color I don't really use anywhere else, so I can delete it easily later. And then I will do all my microcontrollers. Actually, I want to paint this because I've changed my paints. Hold on. Let me... no, I'll do it in files. I'll do it in... If you don't have TCP, go to the workshop. I'll get you a link. Go to this link. It's the workshop page for just all the controllers. Just subscribe to all of them. And then you can search TCP. I've got some results for TCP here in my controllers, and then all the workshop controllers. So the workshop controllers that I have are the ones that you can get. I've made sure that I'm subscribed to them all, and none of the old stuff is in here. As you see them here, I'll just go through them and figure out what I need for this. So what I'm building here is a locomotive, which means it can control the train, and it doesn't have any passenger compartments, so there's no passenger doors and no passenger lights. So I'll go over everything as I go through them. The extender door opener. This is actually just a thing that controls whether or not passenger doors open. Basically, it takes in the door button and unlocks the door, and then it connects to the passenger doors interface. I haven't used this before, but it would be used on passenger wagons or a locomotive that has a passenger compartment, basically to control if the passenger door opens or not. The lightbox extender, this is something that you probably will always need. It takes in the TCP interface data, and it controls the front and rear RGB lights. So I'm going to connect these as I go. So front RGB for me is up here, and rear RGB is over here. And then if we go into the normal data mode, it's got all these on-off outputs, which are for lights. So high beams, I've got no spotlights. Maybe I should put spotlights on here. Should I put 2 spotlights? I'll put one in this middle slot, I think. Spotlight. So that is my front high beam. Do I need a rear high beam? Decorative lights. So decorative lights are like these things here. They don't really do anything. They're not important to anything. Decorative lights. Warning lights. Warning lights I think are hazard light. I always get confused with work lights and warning lights, but I think the warning lights are like your hazard lights, anything that flashes. Front and rear tail lights. These are these things here. These just paintable indicators that look like strips of light. Oh, wait, I've got spotlights down here. Oh, ho, ho. Oh, ho, ho, ho. So front high beams, they can be these ones. Or are those the front headlights? I'll set them as high beams for now. Because spotlight. Well, are more headlights because they're in that enclosure. Front headlights. I'm changing them. Rear headlights, front headlights. So I've got no high beams. Don't worry about that. Doesn't matter if you leave any of this stuff disconnected. This one here, interface, we'll need to connect that whenever I get to the interface. Next one. Decouple interface. Now, I have a custom interface that I want to use. But essentially, the decouple interface, you have this UI node here. And you can, if you read it, it says B4 decouple push N7 car did decouple. What that means is it has a boolean on channel 4 that is a push button, it just takes in a pulse of a boolean signal, and that decouples the cars. I think for this one you actually have to hold it for a couple of seconds, so if you're pushing your decouple and it's not working, just hold it for 2 or 3 seconds. And then N7, so a number on channel 7, and that is the car to decouple. So TCP can decouple between any 2 TCP cars or locomotives in the whole train. If you can decouple from, say, the end of car 8, and it'll decouple 8 from 9. If you're using the TCP UI, the actual display, then you won't need to worry about setting up any of these channels, but it's there if you want to do it. If you want to set things up manually, you can. I don't do it because I think it's too complicated. And then these other things, interface and module, blah, 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 blah. So I need to find my custom one. So interface decouple up here. I'll put my ones on the workshop as well. TCP interface decouple 1x2 display only. I believe this is mine. So it's the same controller, but the video output that goes to a screen, it goes to a 1x2 display rather than connecting into TCP's 2x2 display. And it is locked. You can't change through it. So the TCP 2x2 interface display, it's basically a MFD? A multifunctional display? It's one of those screens that has lots of different screens in it. But I am getting rid of that. And I will have me a decouple screen there. I also have one for my passenger cars, so I'm wondering if I just put that above there, or is that going to be too far away to reach? I'll put it up there for now. So this screen will be decouple and this screen will be passengers. So to connect them, I'm going to take my video out and my touch output back into it. So the one that says UI, you're either going to connect that to like instrument panels that you've set up, or you just connect it to the touch display. What you should be doing, or what they expect you to do, is, so the display controller has a whole bunch of composite inputs and the touch input. So this touch input would come from the screen, and then each one of these goes into the interface. So what have we got? Decouple UI would connect to the UI on the decouple interface. This is essentially a composite switch box, and as you change through the different screens, it just is connecting to a different interface. But because I'm setting it up so that I can't change for any screens, I don't need to worry about this. Next thing, I've got my decouple rear and decouple front. Now I use another custom helper thing, manual decouple. So what I do is I take my decouple rear and I connect it into my TCP decouple rear, my decouple front, and send it into the TCP decouple front. And then these decouple fronts go to the actual couplers. Now you also want to have a NOT gate. I use one that's actually labeled because it confuses me. So the main TCP coupler is that bottom one here. And then the top auxiliary connector is the one that just does the electricity. And I connect one for the front and one for the back. So that's the top and that's the bottom. And so what this is doing is it's saying if this electrical connector is not connected, then release the other connector. And that'll stop you from having weird situations where this top connector tries to connect to the bottom connector of another wagon and gets all offset. So essentially this top one's always on release until this bottom one is connected. So that just connects into there, and then this decouple front will connect to that one, the purple main connector. And then the manual decouple front and manual decouple rear, do I have anything set up for that? I do not. Usually I put a key. Do I want to put a key though? I don't really want to put a key down here anywhere. I think a key would look kind of gross. I will figure that one out later. But essentially, what my manual decouple does is it lets me input a key into this node. Either TCP is going to tell that to decouple, or I can manually override that. It's basically an OR gate that's happening in here. And then the next thing we've got is this interface to module and module to interface. So this is the decouple interface. What I want to find is the decouple module. Module, decouple, that's what I want. And so these two just exist together. So I go interface to module, and then this one here, they're usually right next to each other. Module to interface, module to interface. So a lot of the time you can end up with your controllers right next to each other, like this, where they're just connected directly to each other. And that is a flexibility thing. So then the next things we got from the module is this main both and this hub slot. We'll connect those later when I figure out how many hubs I may need. So we've just done decouple. Next is drivetrain. Drivetrain is like the main thing that makes your locomotive go. And while I'm here, I need to change this throttle to target speed, because TCP works off target speed. It doesn't work off like giving it 100% throttle. It works off how much speed you want to give it. So I want to go 250 kilometers. That'll be max throttle for me, and that is what TCP will try and match. This one has like your speed and your brakes and your throttle. So the current speed is in meters per second directional. I don't have two linear speed sensors. Beats me, but it said directional on the controller, so directional it is. Then we have the throttle, which goes into... Where does throttle go into? Throttle outputs throttle to the motors. I have some motors down here. Motor. Activate engine. It says optional, and it says for remote engine activation, so I don't need that. I have wheel RPS, so somewhere on the wheels I have a torque meter, which for an RPS output. So that same pipe that is delivering power from my electric motors is connected into all my wheels and into the torque meter. So whatever the torque meter's RPS is the RPS that my wheels are actually spinning. That matters because if your locomotive is moving 100 kilometers, but the wheels are spinning at 90 kilometers, then you probably have wheel slip. You might not have wheel slip in that situation. If your locomotive is moving at 50 kilometers and your wheels are spinning at 100 kilometers, then you'll have wheel slip. So that lets the system know it needs to slow down adjust the brakes, etc. It needs to figure itself out. Then we have the brakes. Now the brakes I like to connect to a manual brake override. The brake goes into this one, TCP brakes, and then this goes into the train wheel brakes. I usually have an instrument panel. I want to get the one that I put on the Draken so that it's all consistent, this little thing here. Override switch goes to that, and this goes to that. So I've got this little chain of an instrument where either of these push buttons can set the brakes to 1 or reset it to 0 and then give it whatever TCP is giving it. And this little dial just tells me what the brakes are at. Hopefully. I think this thing is like 11 wide as well. It's quite common for locomotives to be 13 blocks wide, but I think this one was before, more serious about building. I can put it here or I can put it down a bit lower. I'm going to put it here because I'm lazy. So that's my override brakes connected. And then wheel slip, you just connect to any of those wheels. The TCP drivetrain controller, you use that for every set of wheels and motor. So for instance, on the Draken, I have 3 drivetrain controllers. The one master controller is on this back set of wheels. And then I have a drivetrain for the steam wheels and another drivetrain for the front set of wheels. And that is because each set of those wheels could be rotating at a different speed. And so they need to know to apply different amounts of brake or motor power to each one of those wheels. So there is a motor or 2 motors on this front set of trucks. Then these steam wheels have the steam power or the steam pressure coming from the boiler. And then this back set of trucks has another group of 4 motors on it. So they've got different amounts of power output and different amount of wheels. So they need their own drivetrain controller to figure out what they're doing. So there's 3 on here. On the tender has 2 electric motors and like 8 sets of wheels, but they're all connected together. So it only has 1 drivetrain controller. Because if any of these wheels, all these wheels are going at the same speed because they're all connected to the same motor. So if any of them slip, all of them are slipping. There's no different amount of speed that could be happening on these wheels. They're all going the same speed, so they only need 1 drivetrain controller. And so that's the same for this situation. I have 2 motors, which are running 3 wheels, and there's no other sets of wheels, so I have 1 drivetrain controller. UI return, UI interface module. UI on the drivetrain is what you need to connect to the controllers that you need to make that inputs all of this stuff. The microcontroller that picks up all of this instrumentation and feeds back all these lights and stuff, that's what you need to make. You need a microcontroller with all that on it, and that will connect into the UI. The UI return is what TCP can tell you. So if we read it here, B1, we can see emergency pending, B2, remote engine, B3, emergency status, N1, target speed, N2, target brakes. So if you wanted to output on a dial or something what your target speed was, because maybe you're not using a lever to determine that, so you don't actually have that value to look at, then you can pick it up from here if you have to. What I'm going to use this for is to pick up the emergency status, which I think is on B2. B1 is emergency pending, B3 is emergency status. So I need something with I need an indicator that triggers on B3, and the emergency reset is a button you can press. If I look at the UI, B3 emergency reset push. So I can set up a push button to reset the emergency status, and I think emergency set is B3 push. So I can set an emergency and reset it from this locomotive. Activate engine I don't need, that's all set up. So what I need to do is get myself a drivetrain module. Here we go, drivetrain module. And I've placed it down the right way. So interface to module, interface to module, module to interface, module to interface. And then these things here are all the couplers. But these don't connect directly onto the coupler. They connect onto these nodes that are within the system controller. So I'll connect those when we get to it. just did the drivetrain, the exterior lighting. Outputs information to both the lightbox extender and instrument panels. Well, that's this thing. So connect that, I think. Lightbox extender. Okay, so I need this, and I need to connect some more UI stuff to it, which I don't want to do right now. So I'm just going to find the module for exterior lighting. There you go, module interface module, and that connects to main both and the main input or a hub. So for that UI, yeah, I need to set up a system where I can send the reverse signal to this, and where I can output. I don't actually think I want to output any of this stuff. Connect to instruments or display controller channels. Auto light toggle B5 reload. Maybe it's just some light switches I need connected to that. Moving on. Passenger doors. I have a custom controller for this. So this is the same kind of situation as the decouple interface. It's a locked display. You can't change through to the other options. So I just have a custom thing for it because I've altered all the sizes for it to fit on the 1x2 display as well. I'm also going to need a module. So passenger doors module, which I'll just get it now. I don't know, what does it say? Communicates with passenger module, so it's this one. Communicates with passenger door interface. That's those. Now the UI I need to connect to this display, and the video I need to connect to that. That's going to pick up all the touch data. The door opener, if this was a locomotive that had passenger compartment and passenger doors on it, you would connect this to a door opener. Because I don't, it's okay to just leave that off. And I don't know if there's anything else on that one. Then the other nodes we've got here are more nodes that connect into the system, the main input of the system controller. Passenger lighting, I don't think I need this. This is what you have on a passenger wagon, like a coach. Brakes. Okay, these ones here I'll explain real quick. An RO, anything that has RO on it, it's for read only. So they're much smaller and there's basically nothing going on here. So if we look at, say, these decouple ones, there's just nothing on it, right? It's just an interface module connection and a main both connection. This is the normal decouple module. It's got 2 extra nodes versus the RO. It basically just takes away the ability to connect to an interface. So it's good if you are just reading some data and you're not doing anything. You would use that. Some passenger wagons will use that, and some cargo wagons, like if you've got a wagon that's moving containers or something, you would use ROs, because you're going to have no controls on that wagon to tell the locomotive or the train to do anything. A good example of that is there's a brakes only one. So this is an RO interface for a drivetrain with brakes only. So you would use this where you only need a brake output. So if you've got a cargo wagon, it's got no motors, but it's got brakes, so you want to be able to stop it. So you just use this, and it's only going to read from the train what the brake value is. It's not going to do anything else in the drivetrain. I think I've got most of these. The display controller is what you will use if you're just setting up the 2x2 display to do all your instruments, like all your TCP, decouple and passenger doors and stuff. The dual cab controller, if you've got a locomotive that has a cab at each end of the loco, you'd use this. Cab switch, I think you'd use that. The dual cab switch box, use that if you've got a dual cab locomotive. System hub, and then system main controller. That's what we need now. So the main controller is like the core of everything. Okay, this is what we connect to the couplers. So rear coupler, connect to the rear coupler. That'll go to this one. And then there's the other one. We need to receive the data. Rear coupler. And then front coupler. And front coupler. So that's nice and easy. Cab. This is going to be connected to player in cab, B5 cab direction. I wonder if I have that set up in the Draken actually. So I've grabbed this helper UI controller out of the Draken, and this is interpreting all the data from this panel here. Out signal, master panel, master panel. So on this instrument panel, I've got is master, request master, release master, and lock master. Ooh, that's not good. That needs to be lock master. Lock master. That is so another locomotive can't take control from me. So if I come up here and have a look, I'm going 1, 2, 3, 4. I need a connection to go to main both, which is here, and then a connection to go to cab. Now on the cab, request master is 1, release master is 2. I need to copy this. Lock master is 4, and player in cab is 5. Where am I getting that from though? I don't know what player in cab does. It might be one of those like turns off if you fall out situations. But anyway, the thing that says I am the master, I need to change my channels here. So request master is boolean 1. Release master is a push on boolean 2. And lock master is a toggle on 3. And I don't know where is master comes from. When I flip the main both reads channel 1 and it sends a 1 out. Oh, to the cab it's sending 2, 3, 4 and converting it down to 1, 2, 3. So somewhere from main both I'm getting channel 1. So if we look on here, main both, boolean 1, I am master. Okay, so I can just change my controller or I can change my instruments to be 1, 2, 3, and 4. And so the channel 1 is reading off main both, and then 2, 3, and 4 are getting converted over to 1, 2, 3 and being sent to the cab. Now, all these other things that I've got going on here, they all need to connect to main both. That's pretty easy. Okay, this main both, main both, main both, main both. So this connects to a whole bunch of them. Just hold control and go over all of them and just double check you don't need to connect to anything else. And then the other one's main rear, same kind of situation. Connects to a couple of different ones. I think in this case I'm only having to connect to one. Okay, so now this is where you need hubs. I've got one main input, right, into my system. I can take one main input, but I've got a main input here. I've got a main input here. I've got a main input here. I've got one here, and that's it. Okay, it's got three. Got 1, 2, 3. I've got 4. Oh, we get a hub. A hub is like, it's like an electrical multi-box, you know? You can plug one of those things into the wall and then you get like 4 or 6 or 8 extra plugs out of that one socket. So you take the main input and connect that into the main input on the system controller. And then these 3 other slots I can connect to my 3 other nodes. I have 1, 2, 3. Oh no, I've got 4, so what am I supposed to do? You just get another one and plug that one into that first one. You can plug it in anywhere. I think I'll plug it into the front so that it keeps these nodes kind of connected. And then I'm going to connect one main input into there, another main input into there. And then I can just use that other controller and connect my last 2 main inputs. So I've got 4 main inputs all getting chained together and coming into the one main input on the system controller. That's all that does. It's just combining all those signals and bringing it into one. That's essentially TCP, I think. So it's a lot of smaller controllers, just, you know, smushed together. A lot of composite signals going around here. And then I need a UI controller to deal with all this nonsense. I think my track switch is connected, my speed is connected. I don't know where I'm going to put all my lights. Look how I've done the electricity. I used to be real big on doing this because it meant you could kind of clearly see what was connected. But I am no longer a fan of this. I would rather just run it all off the battery. In this situation, there is some reason because there's a relay here and that connects onto these back drawers to make sure they don't drain the electricity, but kind of annoying. When you want to add new stuff into the system, it's annoying to have to go through and figure out what's going to be draining electricity. So here, these are my custom displays. Usually these are expanded out across a 2x2 display, and it would let you change through. You would be able to view decouple, and then you would be able to go out a couple menus and come back into the passenger door module or the passenger door interface. But I just like having them as their own thing. On the 2x2, they're just a little bit spaced out, but otherwise they look identical to this. So the way that the door lock works is you can press these to unlock the left or the right side. And then as you can see, the open lights up when one of them is ready to be unlocked. These numbers here, they're just 1 and 1 because I am currently in the Locomotive, which is number 1. If I had a passenger wagon on me, then I could select this to be either 1 or 2, and same with this one. So you can select the range of cars with this display. You can say I want to open passenger cars from 2 to 3 or 2 to 4 out of a whole train. So you could have 10 wagons and only open, say, the first 2 or the middle 3 or the very last one. You can select with that. Decouple kind of works in a similar way. You can press this and these 2 arrows let you move where you're decoupling from. So at the moment I would be decoupling from the front of 1. If I press this arrow, I would be decoupling from the rear of 1. And then you need to hold decouple for a couple of seconds. I think it's 2 or 3 seconds, and then it will decouple, and then it will be decoupled for a couple of seconds, and then it will try and recouple itself. So you need to move away, or I guess keep holding that button. So the UI is expecting, you see down the bottom though, it's expecting the brakes and the throttle. And then I'm starting the engine on a flip switch on channel 8 for some reason, which is going to come down into this controller, the diesel furnace controller. And we'll just change this to channel 8. Boop, boop, boop. Now this one's a bit weird because I'm using a heatsink for my condenser, so the only thing that's actually turning on in the steam system is the furnace. Just for testing, I'm going to put a diesel tank on the side here. It would be really good to see how many swats I was generating. I could actually put a display up here that tells you some of the information about it running. That isn't really necessary down here. Like, you probably don't need to know the fuel and the battery on this panel, but it would be good if it were somewhere close where you could see. Yeah, it's very good actually to know how many swats you're generating, because at the moment I don't know if I've got enough to move. There's no battery involved in this, so it's just once I'm generating swats I can move. My controller here, the TCP UI, is bringing in the throttle and the brakes, throttle and brakes, and the UI is expecting the throttle on number 1 and the brakes on number 2. UI, we have number 1, brakes, yeah. So at some point, I remember they swapped these around. So throttle goes up there, brakes comes down there. Throttle on number 1, brakes on number 2. Actually, if I set the brakes on this to 0.34, just a random number, we should be able to see on this 0.34. And same on the other side, 0.34. And then if I push the button, it goes up to 1. So this is just showing that my brake controller is interfacing with TCP correctly. It's reading the brakes that I'm sending to TCP, and it's also reading the button that's overriding TCP's brake signal and just applying all brakes. Yeah, I guess you could say that's all you really need to get TCP set up and going. And what I'm doing now is setting up the UI system from all my instruments that will then tell TCP how to operate. So this is more of a debugging phase. If I set my target speed to 40.83, hopefully the speed will eventually pick up to 48. What was it? 40? No, not 40. Yeah, I'm at 40 target speed and we're going 40 kilometers. It's a little bit off because I want 0.83, but you know. Set it to 250 and see what happens. I should put some kind of lock on that door so it doesn't wiggle open. Reverse. Does reverse work? Yes, reverse works. Well, realistically, all I've got to do is figure out what I actually want in the cab of this and get my light switches in here because yeah, I don't have anywhere to turn the lights on from. But that is TCP. Here it is, connected to the Draken. Here I can start the engine and this will generate electricity and then it will send that electricity through that top connector. So even though the Draken's not in control, it's running all its motors and it's sharing the electricity with the motors on this one, on this little steam diesel. And this is also generating electricity and sharing it back into the Draken. But you can see this is the master, so I'll be controlling it from up here. Hopefully that answers some of your questions about how to set up TCP. Let me know if there's something specific that doesn't make any sense, because I'd like to make, you know, some more videos that explain some things. It's very goofy that these two things can work together. Thanks for watching. See you later. Oh yeah, here we go. Decouple. Number 2 is the Draken, and the line is to decouple between these two. There it goes. See ya.